Today we're going to continue with the drug calculations for pediatrics that we have started some few days ago. Today we're looking at the second phase of pediatric drug calculations. Earlier on in the previous videos, we have discussed the age-based rules, where we have there are just three in number. There are three of them. First, we made mention that we have the Young's rule. The second was the Dillon's rule that was mentioned. And then lastly, we also mentioned the Friedman's rule. Now, these are the three rules that are age-based. So these ones, the dose of a drug to be administered to a child has a very strong link with the age of the child, either in years or in months. Of course, we have already discussed that extensively. So you can look at the previous videos on this aspect. Now, the second phase of this lecture series is calculation of drug dose, of course, for pediatrics. But this time around, we are going to be looking at the weight of the child. So weight of the child is the aspect that is going to be considered in this second phase. Now, just like the age-based rules, the weight-based rules or the weight-based formulas, they also have a very strong connection, just like that of the age-based with the adult dose. But quickly, the weight-based rules are also three, just like the age-based. Now, the first one for the weight-based rules is the Clarke's rule. So this is the first one. Then the second one is the Hamburger's rule. The Hamburger's rule. Then lastly is drug dose based on the child's body surface area. So these are the three rules that have a very strong connection with the weight of the child, right? With the weight of the child. And they are not the same in terms of the unit of the weight measurement. In the case of the Clarke's rule, the weight is considered in pounds. The weight is considered in pounds. Then in Hamburger's rule, the weight is considered in kilograms. The weight is considered in kilograms. Then the dose based on body surface area. Two very important things are considered when you want to use this method. First, you will need to get the height of the child. You need to get the height, and also you get the weight. We're going to look at how to go about the third part. It looks very trickish and more cumbersome as compared to the first two. But all of that, we're going to discuss it extensively, how you can calculate the body surface area of a child. Then you can input it into the formula to get the accurate dose for that child. Now let's start with the first one. Now the first one we're going to be looking at is the Clarke's rule. The Clarke's rule. Now, the Clarke's rule is given as follows. Now the dose of a drug to be administered using the Clarke's rule is simply, this is the formula, that the dose is given to be weight. No more age. This time around is now weight. Weight of child. But the weight of the child is in pounds. Is in pounds multiplied by adult dose over 150 over 150. So this is simply the formula for calculating the dose of a drug using the Clarke's rule. Now, for those of us who are in this part of the world, you will notice there is a variation with regards to the unit of measuring weight. Here in Nigeria particularly, the unit of measuring weight that we do use is in kilograms. Kilogram is what we use as our unit of measuring weight in most of our clinics, hospitals, or in our facilities and all of that. So kilogram seems to be the most popular of all the instruments. All of the instruments we use are calibrated in kilograms. So if you are to use this particular formula to calculate the dose that you are going to administer to a child using this formula, that is to say, I have to do an extra work. Very simple work, not too tedious. Now, what is the extra work? So if you want to apply this formula, that means you have to get the equivalent of the weight. If, for instance, I've already weighed the child using our instruments that are calibrated in kilograms here, what I will do is, once I get my weight in kg, I will have to convert that weight in kg into pounds before I can apply this formula. It will be very, very wrong for me to take that weight that I've measured in kilogram, substituting it into this formula. Is very, very, very wrong. It's not correct. It's not going to give you an accurate dose. So that means there should be a relationship between, that is, there should be a strong relationship between pounds and kilograms, between pounds and kilograms. Yes, there should be a very strong relationship between pounds and kilograms. Now, there is a relationship already that have been established. I believe we have also mentioned this in one of the series. I think that is the first class where we said, where I gave the basic conversion factors. Now, if you have not watched that, you can quickly go through the page, that is the YouTube page, to get a glimpse of that aspect of the lecture as well. Now, but let's quickly remind ourselves of the relationship between pounds and weight. Now, this is it. Now, there is a strong connection between kg, that this kilogram or kg is equivalent, right, 1 kg now. 1 kg, 1 kg is equivalent or is the same as 2.2 pounds. So pounds is lbs. So that is 1 kg is equivalent or is the same as 2.2 pounds. So if you have already understood this, or if you have understand this, then it will be difficult. It will be very, very, very easy for you to calculate the dose of a drug, provided you want to apply or use this formula. So irrespective, if the dose, if the weight of the child is in pounds, for instance, you are in a facility where you have your instrument for measuring weight calibrated in pounds, you can easily use that weight without converting. But if you are in a setting where your instrument is calibrated in kg, then of course you have to apply this basic conversion that says 1 kg is equivalent to or is the same as 2.2 pounds. So let's quickly take an example. So if, for instance, we are dealing with a child that is, let's say, 10 kg. If we weigh a child and the child's weight is 10 kg, so what do I do? So this will be 10 kg will be equivalent to what? It will be equivalent to what pounds? So let's denote that with x. So for us to get it, what do? To get the value of x, we have to cross multiply. So if you cross multiply, you have that x is equal to 10. 10 of, even from here you can say this cancel this, like that, but of course you cross multiply, all the units will take care of themselves. So this is x is equal to 10 multiplied by what? 2.2. So this will give us 22 pounds. So a child whose weight is 10 kg will have its weight in pounds to be 22 pounds. So this is very simple, I believe, and direct as well. So just all you need to know is just know the conversion between, or the factor, conversion factor between kg and pounds, which is 1 kg is the same as 2.2 pounds. And whatever you have as your kg, of course, you can put it here, do the substitution and cross multiply. At the end of it, you have an answer. So in this case, 10 kg is the weight of the child that we are going to calculate his drug or her drug dose. And since 10 is the weight, what will be the equivalent of 10 kg in pounds using this basic conversion factor? And that is what we just did. So if you cross multiply, you have that x kg is, well, cross multiply from this side also, you have 10 kg will give us 2.2. So that is to say x at the end of it, at the end of the whole substitution, you have x to be 10 multiplied by 2.2, which of course will give us 22 pounds. I believe this is a very simple and easy. Go back to your basic mathematics with regards to making something or a value a subject of formula. So if you can understand that from your basic mathematics, I believe this should not be a problem. So now we have already established the first part of the calculation, because sometimes in our facilities, in our hospitals, we might have the dose of the child, the weight of the child to be in a unit different from what the formula says, or the formula that I want to use. So it's not a big deal, it's not a problem. You can easily maneuver your ways by using the appropriate conversion factor or factors, as the case may be. Now, if I've understood up to this level, let's see. Now, weight of the child is in pounds. In some of the countries, like in Europe, most times they use pounds as their unit of measuring weight. Of course, we have already mentioned severally that adult dose has been constant ab initio since we started this lecture series. And of course, it's very essential for you to know the adult dose of every drug that has connection with pediatrics. That will help you in understanding how to calculate drug dose. Then, of course, 150 is the average adult weight in pounds. The 150 as this denominator 150 is the average adult dose in what? In pounds. So this is the formula for calculating the drug dose using the Clarke's rule. So let's quickly take at least an example. Now, let's take the example. Example 1. What dose of chloroquine injection? What dose of chloroquine injection? I'm using this reference material as I've told you earlier on. That's what we'll be using for all of the lecture series for drug calculations for pediatrics. So this is the reference material we're going to be using throughout. Now let's take an example. What dose of chloroquine injection will you give to a child whose weight is 15 kg when the adult dose is 5 mils? When the adult dose is 5 mils. Now this question seems to be very tricky with regards to the formula we have here. I believe we should understand what I mean by it's very tricky. If you look at the formula carefully, you will see that the weight of the child rather is in pounds, and from what we have as a question, the weight is given the weight was given in kg. So that is to say we have to do some extra work to get the equivalent of 15 kg in pounds. We need to do some extra work. Now let's quickly look at it. Now let's take our information down so that it will be much easier for us. Now the weight of the child was given to be 15 kg. Then the adult dose was given to be 5 mils. Was given to be 5 mils. So now, what will be the dose that you are going to give to a child? That is dose of chloroquine injection you are going to give for a child whose weight is 15 kg. So this is an example, just an example for us to apply this rule. So we have our information down. Now let's quickly substitute our figures into the formula. Now, to calculate the dose now, to calculate the dose now of this chloroquine injection that we're going to administer to a child whose weight is 15, first thing that we need to do is there is variation with regards to the weight. The formula says the weight is in pounds. The question says the weight is in kgs. That means we have to convert from kg to what? To pounds. So of course we have already established previously that there is a relationship between pounds and kg. And what is the relationship? That 1 kg, that is 1 kilogram, is equivalent to what? 2.2 pounds. So if you have understood up to this level, where we said 1 kg is the same thing as 2.2 pounds, then we can quickly get the equivalent of 15 kg in pounds. What is the equivalent? Now this will be 15 kg. This is 15 kg. What will be the equivalent of 15 kg? Let's denote that with x. Now, what will be the value of x? So whatever we have as the value of x will automatically stand as the value for the equivalent of 15 kg. Now, what do we do? Let me take step by step. If you cross multiply, you have x kg, right? Will be equal to cross multiply to on this side also you have 15 kg multiplied by what? 2.2 pounds. Now, kg here will cancel kg here, right? So our x, let's go to this part. Our x now, our x will automatically be what we have left is 15 multiplied by 2.2 lbs, which is pounds. Now, if you do this, x will be 33 pounds. So this is the conversion process. This is the conversion process. So we have already converted from kilogram to what? To pounds. So that is to say 15 kilograms is equivalent to 33 pounds. So we already have that. So let's quickly utilize this information to calculate the dose that dose of chloroquine injection we are going to administer to a child. Now the weight of the child is now in pounds. So weight is what? 33 pounds as we calculated just now. Then, okay, we must not use the pounds so that the whole place will not be full of values of that. So this will be 33 pounds multiplied by the adult dose was given to be 600. This is 100. The adult dose was given to be, from the equation, was given to be 5 mils, right? Yes, adult dose was given to be 5 mils. Yeah. So from the equation, the adult dose was given to be 5 mils over the average weight of a child average weight of an adult in pounds, which is 150. So here will be what? 150. So here at the end of it, we have 33 multiplied by 5 will give us around 165 over 150. So this will give us 1.1 mil. Give us 1.1 mil. So what does this mean? So that is to say a child that weighs 33 pounds will be administered with chloroquine injection at the dose of 1.1 mil. So I think this is very simple and straightforward. You can take a lot of practice questions. Now, this is all about the Clarke's rule. It's all about Clarke's rule. It's not more than this. The only thing you need to do now is to do more practice for you to perfect the art of calculating drug dose. So this is just that concerning the Clarke's rule. Now the next rule we are going to be considering is the Hamburger's rule, which is also very similar to the Clarke's rule in terms of what they are measuring and what we are using. That is the weight aspect. So now the second weight-based rule that we're going to be considering is the Hamburger's rule. Quickly, we're going to be considering the Hamburger's rule. So This is the third, no, the second rather. The second weight based rule. So the Hamburger's rule is the um, second in the weight based rule. So now it has some similarities, just as we have seen for the Clarke's rule. Now, what is similarity? We're going to also mention that later. But now, this time around, weight of the child is still here, and weight of child is still here. But this time around, the weight is no longer in pounds. The weight of the child is no longer in pounds in this part of the rules or formula. So in this case, the weight of the child is in kg or kilogram. It's in kg, then multiply by the adult dose over 70. Now this 70 is still, or is the average weight of an adult. Just like we have 150 to be the average weight of an adult in pounds. So for kilogram, the average adult weight is considered to be 70. So this is the Hamburger's rule, that the dose of a drug to be administered to a child, you can use the weight of that child in kg multiplied by the adult dose over 70. So that is to say, this particular rule seems to be very, is much easier for especially for people who are in countries where the weight of weight is measured, or the instruments for measuring weight are calibrated in kilograms. It will be much easier for them to just substitute whatever they have measured into the equation without necessarily converting the weight to any other form. So this is much easier, right? Much easier because it's too direct, no second part. Now, we have seen the formula. Now, quickly, we're going to take at least an example to so that we can have a better understanding of this rule. Now, let's take an example. Let's take an example. Now, calculate the amount of diazepam injection. Calculate the amount of diazepam injection you will administer to a child of 20 kg with febrile convulsion when adult dose is 2 ml. When adult dose is 2 ml. Now, what we mean by adult dose being 2 ml is, of course, we are considering adult dose to be 2 ml, which is the same as 10 milligram, because the other palm injection usually comes as 10 milligram in 2 ml bottle, or the volume is 2 ml. So either we can use 10 as the dose for adult, or we use 2 ml. Now, what do we mean by 2 ml? Meaning any of these that you use for this calculation, if I'm using 10 milligram, then I will have to leave my answer in what? In milligram, right? Then if I'm using 2 ml as the adult dose, then to say whatever I have as my final answer will be in mils, or will be in mil or mils, as the case may be. Now, this is the situation. But of course, normally, the other pound comes as 10 milligram in 2 mil. 2 mil. So this is the form of the drug. So whether you're using 10 milligram or you're using 2 mils, it's still going to give you the same thing. Now, let's quickly utilize or get our information down. Now, from the information we want to get, the weight of the child has been given to be what? To be 20 kg. So this child was having a case of febrile convulsion. I want to reduce or stop that convulsion because of the danger associated with convulsion in children. So the weight is given to be 20 kg. Then I've already established or saying that the adult dose is 2 mil from the equation. And okay, we said 2 mil is also the same as 10 milligram, because this is how it comes. in a 10 milligram strength in a 2 ml container, or the volume of this injection is just 2 mils. So now what we want to get now is the dose. So what will be the dose of this particular drug we want to give to a child whose weight is 20 kilograms. So quickly, we don't need to convert anything in this aspect of the calculation because the units of our weight are the same. Here is kg, and while likewise in the equation is also in kg. So this will give us that dose of the drug is going to be, weight is 20, the adult dose here is 2, let's use 2, then the denominator still remains 70. Now if you substitute properly, you have 40 over what? Over 70. So this should give us around 0.57 mil. 0.57 mil. So this is the dose that a child whose weight is 20 kg will take for the injection diazepam. So this will be what? 0.57 mils. So this is what you have with regards to the calculation. So what you're going to do is, we have seen the calculation using mils, right? You can also substitute this mil with 10, because 10 is the strength in which the diazepam comes in. That is for the injection. I think both the tablet and injection comes at strength of 10 milligrams. So if what for as a form of exercise, you can also practice out. Replace these 2 mils with 10, then you can do the calculation. You will see the equivalent of this 10 milligram that I'm going to give will still be in what? In 0.57 mils. I hope it's clear. Well, let me quickly go through it again. Now, this is from the question, we have the adult dose to be 2 mils, and this is the weight of the child, and this is the average adult weight for which is 70 kg. Now, if you substitute this into the equation, you have that at the end of it, you have 20 times 2 will give you 40. Here is 70, and then you have 0.7, 0.57 mil. Then I was saying earlier on that the other pound comes as a strength of 10, so you can replace this with 10 and do the calculation as well. So whatever you have will be in milligram. Will be in milligram. Now, if you have whatever, if any answer you have in milligram, you can also convert it to what? To mil. And if you do that, you're going to still arrive at the same 0.57 mil. So this is how to calculate drug dose using the Hamburger's rule. This is much easier because you don't need to convert from one unit to the other.